Hello guys, welcome back to this advanced level mathematics or combined maths YouTube platform. Through this video series, I am showing most expected problem in future forthcoming any type of examination advanced level, pure maths, applied maths, Edexcel, Cambridge, further mathematics or additional maths. Okay, come back a super problem to algebra problem. uh, to question the problem is available in my WhatsApp platform or the thumbnail or YouTube banner. So please subscribe this and share this to all of your any advanced level students, those are waiting for exams and to go ahead in challenging problem solving. Okay, a nice algebra. See that question: 1 plus x to the power 5 equal a naught plus a1x plus a2x square plus a3x cube and so on up to 5. You know, this type of question we call the binomial relation, binomial theorem. When you expand power 5, you know, there are 6 terms. If you expand power 5, there are 6 terms. 1, 2, 3, 4, we have 6 terms available. We are a0, a1, a2, a3, a4, a5 are numbers, constant, we call coefficients, right? Then find this value, a nice worker. Find this value, that's my problem. Or maybe they ask us a structure type problem. Show that equal to a number, because these are ilakam numbers, values. Therefore, some simplified answer comes a number. We'll complete and come back to this another binomial. Actually, this is look like a binomial question. Yes, that's right. But actually not a perfectly a binomial. You can refer your theory class notes or our theory class lessons in binomial theorem. A special part, coefficient of properties of coefficient of binomial expansion, properties or types of coefficient problem, solvable problems through coefficient. If you refer that note, you can see so many proofs are there in terms of a1, a2, a3, a4 with a naught, something like that, including questions in terms of power n. Okay, we'll see how to answer this one. Here see that a naught, a2 here, x square, a3 here minus, some values are positive, some values are negative. X square, right? A2 coefficient becomes minus, see, minus, okay? A2 coefficient become minus. A4 is positive, yes, positive. And A3 is also minus, okay, right? So simple case. Once you learn only, you know this technique. Some questions we have differentiation involving binomial problem or integration problem, or put some values for x equal 1, x equal 2, x equal 3, or properties of binomial coefficients. Okay, so here my dear student, we are applying if x equal iota, complex number, imaginary value. So those who learn complex numbers, I square equal minus 1, iota square equal to minus 1. In complex number, x equal iy pattern. If any problem including complex number, it has a real part known as x, imaginary part known as y. So I square is minus 1. So put x for I here. We'll see. So 1 plus I power 5 equal a naught plus a1i plus a2x square I square, okay, plus a3 I cube, okay, plus a4 I to the power 4 plus a5 I to the power 5, right? Substitute x for I here and stop that. Now we refer some iota questions, imaginary problems including I. Basically I square is minus 1. What is I cube? What is I cube? I square into I, okay. So I square is minus 1 into I minus I. Okay. What is I to the power 4? I square into I square, or I square square, I square minus 1, square it plus 1, right? What is I to the power 5? That is I square square into I. Okay. So you know I power 4 is 1, I power 4 is 1, and I, that is I. Okay. So can I substitute these numbers or items? 1 plus I power 5. Okay. A naught plus A1 I. Okay. What is I square minus 1, right? I square is minus 1, therefore minus A2. Okay. Plus what is I3? I3 becomes yes, minus I, right? I3 is minus I, so A3I. Okay. What is I to the power 4? That is 1, right? Therefore A4. What is I power 5? That is I, so that is A5I. Okay. Right. Now this problem like a complex number, right? So can I write this complex number? What is a complex number? Basically, if I show the first step, define a number including a real part and the imaginary part pattern when we are writing known as a complex number. I parts and real parts, imaginary part and I real part. Okay, so here a number, the I terms there, without I terms there. So can I rearrange all the real numbers, A naught minus A2, right? Plus A4, okay. This completely real, including without I parts. And now take the I values separately, A1, okay, minus A3 plus A5, right? Oh, wow, problem this one, right? My target all superb, some new question. You never saw such a problem in any type of maths papers or rare cases. Okay, this is the format, all real part plus I part. Okay, this is the complex number format, real part plus I. See, for example, z is a complex number we called x plus iy. Okay, z equal x plus iy. So how to find the absolute value of a complex number, or we call modulus of a complex number, mod value, right? So modulus of a complex number is, put a modulus here, modulus, that is square root of the real part square plus imaginary part square, right? Real part square plus imaginary part is y square. Wow, that's the technique here. This is the complex number format. This is the complex number format. Now take both side modulus of this. Find the mod of the each. Here very important, mod of the 1 plus I separately, but power 5 is available. Okay. Here what is the modular part? Square root of the real square plus imaginary square, right? So can I write the therefore this, therefore take the modulus part, or you can write take the modulus part of the both side. This is a complex number, find the mod value or absolute value. So 1 plus I mod, but here 5 is available. Okay, so here also you can put the modulus value. Mod of a square, a complex number, is square root real part a naught minus a2 plus a4, all things square, okay, plus a1 minus a3 plus a5, right? All things square. Okay. Right. What is the modulus of a complex number x plus I form? Square root of real square plus imaginary square, right? Therefore, a square root of real square plus imaginary square, but completely power 5, right? Square root Here this a naught square, a2 minus a2 plus a4 thing square plus blah blah, right? Now dear student, now take a square, remove the square here too. You know 1 plus 1 2, right? Square root power 5, square root power 5, that side square root. Now to remove the square root, you know the technique, both sides square it, both sides square it. Therefore a naught minus a2 plus a4 square, okay, plus a1 minus a3 plus a5 square, okay. Here square root vanishes, 1 plus 1 2, 2 to the power 5, 32. Wow, super problem. So once you learn only, you know, this technique, this questions comes under the rule or the under theory of properties of binomial coefficient. Refer your theory class notebook and see you have done such a problem in binomial theorem about the property of the coefficients. Okay, come back and a nice question will form the problem. Similar questions, there are many past exam papers, but not n plus 1 something. Okay, see what the next question is. Consider the expansion of 1 plus x power n plus 5, right? 1 plus x power n plus 5. The problem says coefficient of the successive terms, coefficient of the 3 consecutive or successive terms in the ratio 5 is to 10 is to 14, right? 5 is to 10 is to 14. Then find the value of n, right? If I revise the problem once again, consider the binomial expansion 1 plus x power n plus 5. When we expand this, the problem is the ratio of the coefficient of the terms, consecutive terms or successive term. What are that? For example, 10th term, 11th term, 12th term, or 8th term, 9th term, 10th term, or 20th term, 21st term, 22nd term. Their coefficient ratio 5 is to 10 is to 14. Then find the n value. A similar type that is there in the past exams or any model papers, you can see this, but I think no n plus 5, something like that. Anyhow, see another chance to learn another expected question in this future exam papers. Okay, so you know, can I say this expansion 3 successive terms are first term rth term, next r plus 1th term, okay, next r plus second 2 term, r plus 2, right? 3 successive term, rth term, r plus 1, r plus 2, r plus 3 and so on, right? So can I write therefore the rth term is how the rth term of this expansion, I'll revise your binomial, a small part of the binomial expansion, 1 plus x to the power n. What the general format, ncr plus ncrx plus ncr, nc1, nc2, nc no, nc naught, nc1, nc2, nc3, the next one nc2 x square and so on, right? Binomial expansion, the standard form of 1 plus x power n. So why don't you apply here? Rth term of this is n plus 5 c no r, right? Therefore 1 less r minus 1, right? N plus 5, that is r minus 1 is the coefficient, and x to the power some r minus 1, right? The problem is only including the coefficient. Therefore I write r term coefficient is this, okay? What is r plus 1 terms coefficient? N plus 5 CR, okay? Next one similar, TR plus 2 coefficient is N plus 5 CR plus 1, okay? These are the coefficient, the first part coefficient, next part coefficient, The other part, coefficient, right? The questions, they are the coefficients preparing for a arithmetic series or geometric series or something, these three ratios. I'll show the coefficients once again. First term, n plus 5 CR minus 1. First term here, n plus 5 CR minus 1, comma. Next term is n plus 5 CR plus R here, right? R, comma. Next one, n plus 5 CR plus 1. These are the three coefficient, okay? If these coefficient in this ratio, find the n value. Once again, I'll stop the theory, that the problem. I show some theory part. What the answer? NCR. What the answer? NCR. Generally, we call factorial n minus r factorial into r factorial. Okay. For example, what is 10C2 factorial 10? 10 minus 2, 8 factorial into 2 factorial. Okay. See, can I simplify furthermore? Can I write the factorial 10 means what? 10, 9, 8, 7 up to 1 descending product. So can I write this one? 10 into 9 into factorial 8, balance parts, right? Over factorial 8 into factorial 2. This cancel, we have another answer, right? I have shown some technique of the factorial simplification. Okay, come back to the major role of this part. So we will develop some equation here, build up two equation and solve. So the ratio 5 is to 10 is to 14, right? Therefore, this over this, 10 over 5, 2. N plus 5 CR over, okay, N plus 5 CR minus 1 is 10 over 5, that is 2, okay. Now, can I write this simplification of the NCR pattern? How this? N plus 5 factorial over this minus that, n plus 5 minus r factorial into r factorial, okay? This over that. So multiple, can I write this one first? N plus 5 factorial, okay? N plus 5 factorial over this minus this. This minus this, what happened? It goes up numerator. N plus 5 minus that, minus r. N minus r. 5 minus 1 plus 6, okay? Factorial. And r minus 1 factorial, right? So properly complete this part. It's a very important part. You misuse, the answer is a problem struck. The other side answer is 2, right? Try to further simplification here. See, n plus 5 cancel. Can I write this one? N minus r plus 6. The other, n minus r plus 5. The other, n minus r plus 4, and so on, right? So you can write this one, n minus r plus 6 into n minus r plus 5 factorial. With this, they cancel, okay? So balance part here, n minus r plus 6, okay? And what about this one? R factorial, r into r minus 1, r minus 2, and so on. This is r into r minus 1 factorial. With that cancel, right? Therefore, below r. Wow, nice work. Okay. Now, can you cross multiple and rearrange the form and get the equation in terms of n and r? So, cross multiple becomes n minus r plus 6 equal to 2r, okay? Therefore, n plus 6 equal 3 times r, right? So this is the first equation I can collect from here. So the idea is similar, you build up two equations and solve, you can find the both n and the r value. Okay, come back to next equation. These two ratios, 10 is to 14. Can I take the big number here and here, divide 7 over 5. So we write that part now. The expected problem, any type of pure maths paper under the binomial relation for structure type or essay problem. Okay, so the next one, n plus 5 CR plus 1 over n plus 5 CR, okay, equal to 14 over 10, right? Or otherwise cut by 2, 7 over 5. Simplify this in the combination, that pattern. So n plus 5 factorial, okay, this minus this, that is n minus r plus 4 factorial into r plus 1 factorial, okay, and come back. I should multiple this one, so I complete the below that part. This is n plus 5 factorial. Okay, next this minus that, that is n minus r plus 5 factorial and r factorial. Okay, n plus 5, we already shown this pattern. The other side, 7 over 5. Now see, like earlier, n plus 5 and plus 5 cancel. This is r plus 1 into r factorial. So it's cancel. You have here r plus 1, right? And n minus r plus 4, n minus r plus 5, n minus r plus 4 factorial. Cancel here. It becomes that n minus r plus 5, okay? That's equal to 7 over 5, right? So can I rearrange, get the second equation, cross multiple 5n minus 5r plus 25, is it okay? 7r plus 7, right? So if I rearrange 5 into n plus 5, this number here, r plus 1, 7, is it okay, right? 5n plus 2, rearrange, right? Wait, take the similar equation. 5n equal, take 12r minus 18, okay, 12r minus 18. Or otherwise better, the question is find the n value. So this is something like this, okay, 12r. This I take my first one, second equation. So try to remove these two to find the n answer. You can solve this pair of simultaneous equation by any method. So can I get 1 comma 2, 1 comma 2. So what is 5n plus 18, okay? What is 12r? 4 times 3r, 4 times 3r, 3r n plus 6. Well, you can divide also. If you divide, r cancel, right? Now rearrange, yes, super problem. Say 24 minus 18. I hope you enjoy this my video series, especially this question. So please subscribe and share this. Then daily problem solve, I can send it like this: advanced level, combined maths or pure maths, applied maths problem solving. All are future expected problem only. This I said, the paper out video series. Okay, bye.